Welcome back, class, and today we are going to continue with section 4 of chapter 3 on logic. And so today we're going to talk about truth tables for the conditional and the biconditional statements. And so here are the objectives for today. We're going to understand the logic behind the definition of the conditional, construct truth tables for the conditional statements, understand the definition of the biconditional, and then construct truth tables for biconditional statements, and then determine the truth value of a compound statement for a specific case. So very similar to the last section, except applying it to conditional and biconditional statements. So if we construct a truth table for conditional statements, remember it's an if-then. So in this case, we have the antecedent followed by the consequent. So if P, then Q, or P implies Q. And so in this case, we got to figure out that when can somebody call you a liar? Okay, so that's the thing. When can somebody call you a liar? If this is true, then the consequent must be true, because if this happens, this is saying then this will happen. This causes this to happen. Okay, so if this is true, then Q must also be true. So when can you say that I lied to you? Well, give an example. Well, here, if I say to my son Brandon, if you get 100% on your spelling test, I will take you out for ice cream. Well, when can you say that I lied to him? Well, if he gets 100% on his spelling test and then I don't take him out for ice cream, then Brandon could say that I lied to him. But what if he doesn't get 100% on his spelling test and I decide to take him out for ice cream anyway? Did I lie? And some people may be tempted to say, well, yes, because you didn't stick to your word. I said, well, not really, because I didn't say anything about what I would do if he did not get 100% on the spelling test. All I said was, if he gets 100% on the spelling test, then I will take him out for ice cream. I didn't say anything else about any other situation. So the only time that you can say that I lied really is if this is true, right? If he does get 100% on his spelling test, but then I don't follow through on what I said I was going to do, if that happened, which is taking him out for ice cream, then you can say, well, you lied because you said this and you didn't do it. Okay? If he doesn't get 100% on his spelling test, then all bets are off. Whatever I decide to do is up to me. Okay? Or if he does get 100% on his spelling test and I take him out for ice cream, obviously I kept my promise and you can't say I lied. So the only time this implication or conditional can be false is if the antecedent is true and the consequent is false. So anytime you have a T followed by F in this situation, again, just make sure you follow the pattern. But if you have T followed by F, then it's false. Otherwise, it's true. So now we construct a truth table for this implication by first setting up the possible combinations, just like before. So TTFF, TF, TF. And then now that we're dealing with negations in here, let's just make two more columns with the negations. So the negation of Q is FTFT. The negation of P is FFTT. And now we take these two columns here and we look down the rows. Now remember, this is the antecedent, this is the consequent. So if this is true and this is false, then this is going to be false. Otherwise, it's true. So we just look and see which one has TF, and it's this one. It's the only row that is TF. So this is going to be F. The rest of these are going to be true. Now you can reverse and negate the antecedent and consequent, and the statement's truth value will not change. So remember that. We can reverse the direction of the arrow and negate both the antecedent and the consequent, and the statement will have the exact same truth values. Okay. So for example, if I say, if you're cool, you won't wear clothing with your school name on it. Right? So there's your P. Let's say P is you're cool, and Q is you won't wear clothing with your school's name on it. So this would be P implies Q. Or I could say, if you wear clothing with your school's name on it, you're not cool. Isn't that saying the same thing? But in this case, this is not Q, or excuse me. Yeah, this is not Q implies not P. So if not Q, then not P. But these are saying the same thing in English, right? So these should have the same truth value. Now, if the fashion tip above is true, then so is this. And if it's false, so is this false as well. Okay? And in this case, it's saying the same thing. Okay? So we would say that those are equivalent statements. They have the same truth values for all possible values of P and Q. So now, if I want to construct a truth table for this implication right here, so this is an implication because this is the dominant symbol. Okay, so now if I do this, I got to do this piece by piece. And so I'm going to start with P and Q again. So P and Q, right? T, T, F, F, T, F, T, F. Now I'm going to start with this piece here. Now I would start, you could start with the negation too, since that's an easy one too. So these rows don't have to be in this order. You could have not P here and have FFTT, but again, it really doesn't matter. So now P or Q. So P or Q, remember, or statements are false only when both P and Q are false. So this is the only one, so the rest are going to be true, and this is going to be false. And then these have the opposite truth values because it's the negation. Now we're going to put these together with and. So now I'm going to take these two columns and to figure this one out. And now this is an and statement. Okay, so that means that this is going to be true only when both statements are true. So we're going to look at down this row and find TT. So this one is the only one that has both T. So it's FFTF. And then finally, we start with the implication. So now we're going to look at this one. This is the antecedent, and this is the consequent. So now we got to be careful here. Okay, so what we need to do is look at this column here. This is the consequent, and this is the antecedent. Okay, so that means if this is true and this is false, then this is going to be false. So we look for true and false. Well, this is false. Well, these are the antecedents, so this is false. 1, 2, and 3 are false. As soon as the antecedent is false, this has to be true. The implication has to be true. Now, this is the only true one, but look, this is also true. So that means it's true as well. So we get all trues down the column. So what kind of statement is this? What do we call this statement, this compound statement, if we have t's all the way down the column. It's called a tautology. Okay, so remember that. This is a tautology. That means this is always true no matter what the truth values are. Now, the biconditional statement basically is an implication that goes both ways. So it's if and only if. So P, if and only if Q, which means we're going to say if Q, then P, and then P, if P, then Q, which is the only if. So we say P if Q, which is the same thing as if Q, then P. That's this one. And then P only if Q is the same as P implies Q, which is this one. So that's where the if and only if comes from. So now if we want to do a biconditional, one way to think about it is, well, in a biconditional, remember, the biconditional is true when both the simple statements that are connected by the double arrow have the same truth value. Otherwise, it's false. So that means this is going to be true, and this is going to be true because they have the same truth value. NC, true, and true. If they have different truth values, then they're false. Okay? Or you could write out in symbols this and this. Okay, and do the table with this one, and you'll get the same thing. So here are the definitions of symbolic logic. Okay, so one, negation, which is uses the tilde, which means not. So the negation of a statement has the opposite meaning as well as the opposite truth value from the statement. Conjunction has the upside down V, or the A without the crossbar. Okay, and, which means and. And the only case in which a conjunction is true is when both component statements are true. A disjunction, which is like the little case V, which means or. The only case when a disjunction is false is when both component statements are false. For conditional statements, which is the arrow, which means if then, or an implication, the only case that a conditional is false is when the first component, the antecedent, is true, and the second component statement, the consequent, is false. And then the biconditional, which means if and only if, that's the double arrow, means it goes both ways. The only case in which the biconditional is true is when both component statements have the same truth value. So either both true or both false. So now, let's take this example. It says, you receive a letter that states that you have been assigned a super $1 million prize entry number, 665567010. If your number matches the winning pre-selected number and you return the number before the deadline, you will win $1 million. So how would we do this? Okay, it says, how would you write this truth value on as far as truth table, right? So it says, if your number matches the winning pre-selected number and you return the number before the deadline, comma, you will win $1 million. So before the comma, everything before the comma is together. So that's where the parentheses are going to come in. And then if that's true, then you win $1 million. Okay? If they don't give you the $1 million, then they lied. Okay, now it says, suppose that your number does not match the winning pre-selected number. You return the number before the deadline and only win a free issue of the magazine. under these conditions, can you sue the credit card company for making a false claim? And the answer is no. Okay? So now, how do we know that that's no? Well, in this case here, they're saying that your number does not match the winning number. Okay? So now, think about it. It says if your number matches the winning pre-selected number and you return the number before the deadline. So it's an and statement. So this is going to be in parentheses. So we have this and this. Okay, so let's say this is P. This is Q. And this is R. Okay, so it says let's say you don't match the winning pre-selected number. Well, that means this is going to be false. You returned the number before the deadline, so this is true, but it's an and statement, which means the whole thing is false. And since this is an implication, well, that means the antecedent is false and the whole thing has to be true. Okay, so you can do this without the truth table. But let's go through this and assign letters. So again, they assign letters, right? So P, your super $1 million prize entry number matches the winning pre-selected number. That's false, right? They're saying you don't. You return the number before the stated deadline. Q, that's true. And R, you win $1 million. That's false because to make matters worse, you were duped into buying a magazine subscription. Dun dun dun. Okay. So we set it up in symbols. So if then, right? So this is implication. If then, your matching number wins the your matches the winning number. That's P, and you return it before the deadline. So now again before the comma. So these are in parentheses. Then R, you win $1 million. Okay. So let's use a technique of just replacing the P's and Q's with the F and T's, right? So this is false. This is true. This is false. So right now, this is going to be what? False, because they both have to be true in order for this to be true. So this is false. False then implies false. Well, the only time this can be false is if we have F followed by T. Well, this is not F followed by T, so this has to be true. So our truth value analysis indicates that you cannot sue the credit card company for making a false claim because they only said that if you do both, match the number and return it by the deadline or before the deadline, then you will win $1 million. Okay. Okay, so now we're done with the section. So this is a quick section. So now we're done. This is a quick section. So what we're going to do now is, again, make sure you're practicing these. Okay, these videos are not going to be very long. Some of them will be, but most of these are not going to be very long. So it's up to you to make sure you practice these and do some of the examples. There are other examples in the textbook. There are the suggested homework problems that I don't collect that are on Blackboard that you can do for practice. If you get stuck on any of these, or if you don't understand how I did these, please write your questions down. Bring those to class so we can work on those in our groups or work on them individually. Ask questions, because that's where your learning is really going to happen. And again, I'm going to keep saying this over and over again. Make sure you're watching these videos before the date that we cover these in class. Okay? So until then, I'll see you in class. Have a great day.